Are we from Mars? A tale of cosmic origins. In the vast and tumultuous expanse of the early solar system, chaos and creation danced together in a delicate, destructive harmony. Planets collided with titanic force, asteroids crisscrossed the void with reckless abandon, and the fledgling worlds that orbited our young sun struggled to find stability. Among these nascent celestial bodies were Earth and Mars, two rocky planets blessed with the raw ingredients for life. But a question lingers at the edge of scientific inquiry and imagination: did the story of humanity truly begin on Earth, or might our roots trace back to the mysterious red planet? Billions of years ago, Mars was a world strikingly different from the barren, dusty landscape we see today. Evidence suggests it was a planet of rivers winding through valleys, lakes that mirrored an ochre sky, and perhaps even sprawling oceans that lapped at ancient shores. Its atmosphere, though thinner than that of Earth, retained enough density to trap warmth and nurture a climate capable of supporting life. In such a cradle of potential, it is conceivable that microbial life could have emerged, flourishing in mineral-rich waters and basking under the dim but steady glow of the early sun. Meanwhile, Earth, its younger sibling in the cosmic family, was still in the throes of violent transformation. Its surface was a molten, roiling expanse of lava flows and volcanic eruptions. Frequent meteor strikes brought both devastation and crucial building blocks for life, but the conditions for anything resembling biology were far from ideal. For millions of years, Earth was a turbulent, inhospitable place, an unlikely stage for the origin of life. Then, a cosmic event unfolded that would forever link the fates of these two planets. A colossal asteroid collided with Mars, gouging massive craters into its surface and ejecting fragments of the planet's crust into the blackness of space. These fragments, some no larger than a pebble and others as big as boulders, began their journey across the vast interplanetary distances. Contained within these pieces of Mars were perhaps not just minerals and rock, but the building blocks of life, or even microscopic organisms themselves. Encased in protective layers of rock, shielded from the hostile vacuum of space and the deadly radiation of the sun, these Martian seeds may have survived for eons as they drifted toward a new home. Some of these fragments eventually found their way to Earth, pulled in by the planet's gravitational embrace. Upon entry into Earth's atmosphere, their fiery descent might have sterilized the surface, but the interior could have remained untouched. When these fragments landed, they encountered a planet that had, at last, become a sanctuary for life. Oceans swelled with nutrient-rich waters, continents began to stabilize, and the stage was set for biology to take root. The Panspermia hypothesis, a theory suggesting that life can travel between worlds on meteors and comets, proposes that life on Earth might owe its existence to this interplanetary migration from Mars. As Earth thrived, Mars began its descent into desolation. The once protective magnetic field of the red planet weakened, leaving its atmosphere vulnerable to the relentless assault of solar winds. Over time, this erosion stripped Mars of its life-sustaining air, causing its water to evaporate into space or freeze beneath the surface. A planet that might have teemed with microbial ecosystems became a barren wasteland. If life had indeed started there, it either retreated underground, adapting to the harsher conditions, or vanished entirely. In stark contrast, Earth flourished. Life evolved in countless forms, diversifying and adapting to every environment. Among these life forms, after billions of years, arose humanity. Modern science continues to probe this cosmic mystery. Robotic explorers like the Mars rovers tirelessly scour the Martian landscape, searching for signs of past life in the sediment of ancient riverbeds and the mineral composition of rocks. Meteorites, confirmed to have originated from Mars, are meticulously studied for traces of organic compounds, the chemical fingerprints of life. Although no conclusive evidence has yet been uncovered, the possibility that humanity might be the descendants of Martian ancestors remains an enticing and provocative idea. The implications of such a discovery would be profound. If we are, in essence, children of Mars, it would redefine our understanding of life's origins and the interconnectedness of the universe. It would suggest that life is not an isolated phenomenon, confined to a single world, but a tenacious force capable of crossing the immense gulfs of space. Moreover, it would frame humanity's growing ambition to set foot on Mars not merely as exploration, but as a homecoming. Regardless of whether our lineage began on Earth or Mars, one truth is undeniable: we are beings of the cosmos. Forged from the remnants of ancient supernovae, our atoms were born in the hearts of dying stars. The same cosmic processes that shaped Mars and Earth shaped us as well. As we cast our gaze skyward, dreaming of the day when humans might walk on the red planet, we are reminded of our shared heritage with the universe. Perhaps, in seeking Mars, we are not just exploring, we are reclaiming a piece of our story.